Ladies and gentlemen, physics. Physics, the fundamental science that unravels the mysteries of the universe. It's not just a subject confined to laboratories and equations. It's a captivating journey into the very fabric of existence. It serves as our compass, guiding us through the uncharted territories of the unknown. From the enigmatic depths of quantum mechanics to the awe-inspiring expanses of cosmology.
Did you know what is kinematics? So kinematics is a branch of physics that deals with motion without considering the forces causing that motion. It only focuses in analyzing and observing its position, velocity, acceleration, and trajectory of that object, providing framework to understand how an object works without delving into the reason behind all of those movements. For example, so when I drop this pen, you can think about how long does it take to reach the ground. By kinematics, you can provide the answer.
You know about measurements and conversion of units? Now, let's talk about it. Measurements are ways we quantify things like length, weight, or time. Units are the labels we use for those measurements, such as meter for length and grams for weight. Conversion of units involve changing one unit into another unit. These are examples of unit conversion. For example, this bus measures approximately 9.5 meters and I want to convert this into centimeters. First, I need to multiply it by 100 because 1 meter is equivalent to 100 centimeters. So, 9.5 times 100 is equivalent to 950 centimeters. Think of units like languages. Expressing measurements and conversions are like translating between languages to make the information more understandable.
Force and motion are essential concepts in physics that help us understand how objects move and interact with each other. Force is a push or pull that can change an object's motion, while motion is the change in an object's position over time. For example, I will kick this ball. I apply force to it, causing it to move and change its position. This demonstrates the relationship between force and motion, illustrating how force can influence the way objects move in the world around us.
Equilibrium stems from the Latin words atrius, which means equal, and libra, which means balance. There are two types of equilibrium, static and dynamic. Dynamic equilibrium is a state where bodies are moving at constant velocity. Now picture a car traveling along a straight road at constant speed. The car is in dynamic equilibrium. The forces are acting on it are balanced. The forward force from the engine is equal to the resisting force, such as the air resistance and the friction from the road. Despite the motion, there is no acceleration, and the car remains steady. This scenario amplifies dynamic equilibrium in the context of constant linear motion, showcasing balance between applied force and resistive force. Static equilibrium. It is a state where bodies are at rest. Look at this seesaw. Two students with different weights are sitting on the other end. Initially, the seesaw is tilted, but eventually it becomes horizontal and stationary. This scenario represents static equilibrium, where the forces exerted by the students are balanced and the torques or rotational force on the seesaw are equal.
Let's not forget the words of Richard Feynman.
physics is like sex. Sure, it may give some practical results, but that's not why we do it.
We delve into physics not merely for its practical applications,
but for the sheer joy of unraveling the mysteries of existence. This is Cadet Dublin,
Cadet Posas, and Cadet Flordelis,
Cadet Gaco.
and Cadet Somotia.
Thank you for watching!
the enigmatic depth of quantum mechanics to the awe-inspiring
Measurements and conversion of minutes.
Go. For example, I will kick this ball.